Hello students, welcome to Unacademy. So myself Krishna Prakash, you know it very well. Students love to call me EE sir or KP sir, most famous for environmental engineering. And now I am here to discuss regarding GATE 2022 Civil Engineering Environmental Engineering paper solution. Do remember this? Yesterday response sheet is released. So from the actual questions from GATE exam, we are going to solve the questions. Total hardness in raw water 500 mg per liter at CaCO3. The total hardness in raw water expressed in milligram equivalent per liter. Do remember, not milligram per liter, milligram equivalent per liter. Total hardness mg per liter at CaCO3 given. You need to convert to total hardness milli equivalent per liter, MEQ per liter. The students who attended my courses, they know very well. I used to give a shortcut formula. X in mg per liter at CaCO3 equal to X in milli equivalent per liter into equivalent weight of CaCO3 50. Direct, straight away question. Straight away. So this is given 500. This is given 500. And this is required. Total hardness in MEQ per liter required. So simple, na? So total hardness in MEQ per liter is equal to 500 by 50. Answer is 10 milli equivalent per liter. Answer is 10 milli equivalent per liter. Guys, do remember, when I start chemical quality analysis in water quality, first I will give you unit conversion. Milligram per liter to mole per liter, milligram per liter to equivalent per liter, milligram per liter at CaCO3 to equivalent per liter, milli equivalent per liter, unit conversion. So from that, directly from our notes, we are having the same question. Even I solved in one of the plus course by taking total hardness as 500. Value also matched. For wastewater coming from wood pulping industry, chemical oxygen demand and 5-day biochemical oxygen demand were determined. For this wastewater, which of the following statements are correct? So here I would like to inform one thing. It may be wastewater from X industry, Y industry, Z industry, wood pulping industry, fruit industry, food industry. Not required, not considered. COD always greater than BOD5. No doubt. And sometimes COD equal to BOD, that to ultimate BOD, not to 5-day BOD. When biologically inactive organic matter is absent. When biologically inactive organic matter is absent, in such a case, COD equal to BOD, that is ultimate BOD, not 5-day BOD. COD never equal to 5-day BOD. So answer is option A and B. Henry's law constant for transferring oxygen from air into water at room temperature 1.3 millimole per liter per atmosphere. So I will tell you here, simple layman approach. Oxygen is 1.3. Oxygen is 1.3 millimole per liter per atmosphere. What is the meaning of it? For 1 atmospheric pressure, oxygen concentration is 1.3 millimole per liter. Given that partial pressure of oxygen in the atmosphere is 0.21. So now partial pressure is 0.21. So what is oxygen concentration? For 1 atmosphere 1.3. For 0.21 atmosphere, what is it? 0.21 into 1.3. Simple, no? 0.21 into 1.3. So what is the answer? 0.21 into 1.3. How much you are getting? Which is in millimole per liter. Do remember this. 0.273 into 10 power minus 3 mole per liter. So I am converting millimole per liter to mole per liter. I am converting, so that I am taking 10 power minus 3. I am taking the reason behind that conversion millimole to mole. Now, the concentration of dissolved oxygen in mg per liter. Again, unit conversion, I think you do remember. Always I use it to solve questions using unit conversion shortcut formula. X in milligram per liter is equal to X in mole per liter into molecular weight of X into 1000. This is only our shortcut formula. So many questions we solved in the class based on this. Now oxygen milligram per liter required. Oxygen milligram per liter required. Oxygen available mole per liter 0.273 into 10 power minus 3. We know molecular weight of oxygen, which is already given, 32 into 1000. Now, what is the answer you are getting? Just multiply it easy. Unit conversion, you know, you can solve the question very easily. 8.736 milligram per liter. Option A. Option A is correct. In a water sample, the concentrations of calcium and magnesium and HCO3. Calcium, magnesium, HCO3 minus. 3 concentrations provided. Then atomic masses of various elements given. Total hardness and temporary hardness in the water sample. So we know total hardness, calcium concentration into 50/20 plus magnesium concentration into 50/12. Easily you can take this, no? Calcium concentration into 50/20 plus magnesium concentration into 50/12. Calcium 100 into 50/20. Magnesium 36 into 50/12. You are getting here 400. 400 mg per liter as CaCO3. Now solve for total alkalinity. Bicarbonate given 122 into 50 by bicarbonate concentration 61. So that is equal to 100 mg per liter as CaCO3. So total hardness is 400, total alkalinity is 100, TH greater than TA. So what is a temporary hardness? Temporary hardness is CH. CH is equal to TA. CH is equal to TA, so answer is 100. 400, 100. Array, all are coming option A. See, 100, 400 and 100, temporary total hardness 400, temporary hardness 100. So this is also option A, 8.7. This is A and B. This is also option A. See, most of our environmental questions are coming A, option A. Wastewater sample contains 2 nitrogen species, namely ammonia and nitrate. Consider atomic weights. In this wastewater, concentration of ammonia 34 milligram per liter, concentration of nitrate 6.2 milligram per liter. Total nitrogen concentration. Total nitrogen concentration. Do one thing. What is ammonia concentration? Ammonia concentration 34 milligram per liter. Ammonia concentration 34 milligram per liter. This is concentration. And what is ammonia molecular weight? nitrogen 14, 3 hydrogens are there, ammonia molecular weight is 17. Now you need how much nitrogen is present in the ammonia. Nitrogen molecular weight is 14. Just unitary method. One ammonia contain one nitrogen. One NH3 contain one nitrogen whose molecular weight is 14. So ammonia is 34. What is nitrogen? 34 into 14 by 17. So nitrogen in ammonia is 28. Nitrogen in ammonia 28. Same you apply for nitrate also. Same consider for nitrate also. Please do take same for nitrate also. NO3 minus, its concentration is 6.2 milligram per liter. And what is NO3 molecular weight? NO3, nitrogen 14, oxygen 3 into 16, 62 is molecular weight. Concentration 6.2, molecular weight. Please do check this. Molecular weight 62. Again, NO3 is 6.2 with molecular weight of 62. What is N value? Understand this. N in NO3 required. That's it. So we don't want to take molecular nitrogen N2. N in NO3 required. That's it. So N is equal to 6.2 into 14 by 62. 1.4 mg per liter. So now if you calculate total nitrogen available, N in ammonia, N in NO3, 28 plus 1.4, 29.4 milligram per liter. It is a NET question. So up to 1 decimal, round off to up to 1 decimal, 29.4 milligram per liter. Means like this, so many unitary method I made you to solve in the class. Same like that unitary method, don't think too much. Direct answer you will get it. A 2% sewage sample, 2% sewage sample was incubated for 3 days at 27 degrees Celsius. After incubation, oxygen depletion, DO depletion is a 10 mg per liter. BOD rate constant for same temperature 27 and 0.23 per day. Now ultimate BOD required. So 3 days 27 degrees Celsius BOD, depleted oxygen into dilution factor. Dilution factor is 100 by 2, 50. So 3 days 27 degrees Celsius BOD is 500 mg per liter. Ultimate BOD YU 3 days 27 degrees Celsius upon 1 minus e power minus kT, 500 upon 1 minus e raised to minus 0.23 into 3. You will get the answer 1003.16 mg per liter. But it is mentioned round off to nearest integer. So take 1003. Nearest 1004 is not nearest. 1003 is nearest. So nearest integer is taken as 1003. A water treatment plant has a sedimentation basin of depth 3 meter, width 5 meter, length 40 meter, inflow rate discharge Q 500, removal fraction of particle means efficiency required, settling velocity Vs is given 1 meter per hour. Particle density, liquid density not required here because check here, efficiency particle removal fraction required, Vs by V naught. If you want to calculate settling velocity Vs, you need densities. Not required, Vs directly given. V naught is equal to discharge by surface area, plan area, Q by LV. Discharge 500 meter cube per hour, length 40 meter, width 5 meter. So what you are getting here, 500 by 40 into 5, 2.5 meter per hour. So fractional removal, Vs is 1, V naught is 2.5. 0.4 is the fraction of removal of particle. If they are asking about percentage, take 40%. As they are asking about fraction of removal, take 0.4. One more question they asked, theory question. Saline water to fresh water. Removal of salt. Removal of salt. I forgot to place the slide. Removal of salt, what we call saline water to fresh water, desalination. Desalination. In desalination, very clearly I have given 4 methods. Desalination, reverse osmosis, electrodialysis. And other 2 methods required for desalination are freezing and distillation. But in options what they have given, electrodialysis, reverse osmosis, microfiltration, ultrafiltration. Don't take microfiltration, ultrafiltration. Only reverse osmosis, electrodialysis. Because microfiltration, ultrafiltration is used for contaminated water to remove physically suspended, biologically suspended matter, not for salt removal. Salt removal, desalination is carried out by reverse osmosis, electrodialysis, freezing and distillation. Please check our notes in sources of water. Very clearly it is given. And here I would like to happy to announce that each and every question of environmental engineering is from our plus class notes. So those who attended my full length course, they experienced the feeling. Everything is from the notes only, not even a single question from outside. So do attend the classes properly and regularly. Join Unacademy Plus or Iconic subscription using the code KP Civil Life. Today I am launching Open Channel Flow, 16th February I am launching today itself. New batch is going to start. So join Unacademy Plus or Iconic subscription. You know the universal code KP Civil Life. And I am going to release next set 2 environmental engineering questions video soon. Stay tuned to our YouTube channel. Thank you one and all.